Now we're going to take a look at isosceles and equilateral triangles. So an isosceles triangle is a triangle that has two congruent sides. Now those congruent sides are called legs, and the third side is called a base. And this doesn't matter what way my triangle is facing. So if I have this isosceles triangle, use your imagination, then these green sides are still called the legs, and the red side is still called the base. So the base doesn't mean the bottom. The angle opposite the base is called the vertex angle, and I kind of remember it as it's the one that is making a V with your congruent sides. And the angles opposite the congruent sides are called base angles. And you can get those, there's my congruence marking, go across, that's a base angle. Congruence marking, go across, there's my other base angle. And those angles are also congruent to each other. So my two sides, my legs, are congruent to each other, so equal, and the base angles are also equal. So if a triangle has two congruent sides, does the triangle have two congruent angles? I guess we're going to prove that. So the isosceles triangle theorem says if two sides of a triangle are congruent, then the angles opposite the sides are congruent. So if I have that right side corresponding with this base angle, the left side corresponds with the other base angle, those base angles are congruent. Just a reminder, that's our congruent symbol. And the converse means I'm going to switch that around. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. And this is the one I see people miss more often. So if this base angle, if I have two congruent angles, then the sides opposite them are also congruent to each other. So I like to draw my little arrows to let me know which sides and which angles are congruent. And now we can use these theorems to help us solve problems. So in this example, we're going to try to find the measure of angle E. And if I look, I have two congruent sides, which means I'm dealing with an isosceles triangle. So I'm going to draw my little arrow for me to find my base angles. And look what I've been given are those two base angles. Once again, it doesn't matter that they're on the top. So I can set them equal 5x equals 3x plus 14 minus the 3x. So 2x equals 14. Divide by 2. So x equals 7. My question said to find the measure of angle E. So to find the measure of angle E, I'll plug it in up here. 3 times 7 plus 14. So 21 plus 14 is 35 degrees. Let's look at the next one. So this one we want to find the measure of angle C. Well, I notice I have an isosceles triangle because I have two congruent sides. So let's find our base angles. So across from one side, across from the other. So notice on these I don't have anything, any angle measures for those base ones. So I'm just going to call that x. And now I can use my triangle angle sum theorem that all the angles in a triangle add to 180. So x plus 78 equals 180. And I'm going to use that to solve for x, which is going to correspond with angle C. So 2x plus 78 equals 180. Subtract the 78. So 2x equals 102. And divide by 2. So x equals 51 degrees. And like I said, x is equivalent to angle C, so I'm done. Next one is really similar. So I have an isosceles triangle because I have two congruent sides. So that means angle Q and angle P are my base angles. They also have not given me a value for either of those, so I'm just going to call them x. And we'll set up the same type of equation. So x plus, can't tell if that's a 56 or a 66, so we're going to go with 56, equals 180. So 2x plus 56 equals 180. We'll subtract that 56 over. So 2x equals 124, and divide by 2, so x equals 62. And if I had 30 years in the world, I would sit here and double check all my work and make sure that they're adding to 180 degrees. So let's try another one. Once again, it's isosceles because I have two congruent sides. So looking at what are my base angles, going opposite my side, so I have angle J and angle H, and for this one they have given me both of those values so I can set them equal. 8x equals 6x plus 18, so minus the 6x, and divide by 2. Look at my question. My question was the measure of angle H, and H is 8x, so I'm going to do 8 times x, so 72 degrees. Once again, I have the same setup in number 4. They're giving me the two base angles, so I set those equal to each other. Subtract x from both sides, and x is just equal to 30 degrees. That was kind of boring. Now we need to find the measure of angle M. M is x plus 30, so 60 degrees. So speaking of things that are 60 degrees, let's talk about equilateral triangles. So equilateral means that all of my sides are equal. And if a triangle is equilateral, then it's equiangular. Let's break that up. Equa, so it's equal, angular, angles, so equal angles. And then we can go the other direction. If a triangle is equiangular, so it has equal angles, then it means it's equilateral. So in this diagram over here, I have 3 congruent angles, which means I also have 3 congruent sides. Now, since we're talking about a triangle that has 3 angles, and they all need to be the same, think about it. If I called these each x, and I did this, add them all up and they equal 180, so 3x equals 180, then x equals 60. So that means in any equilateral triangle in the whole wide world, the angles are always going to be 60 degrees because they have to be equal, all equal, and the only way to have that happen is if they're 60 degrees. So you can kind of use that as a shortcut. So in this first example, that's what they've done. Since it's equilateral, that means each angle must equal 60. So they said 7x plus 4 equals 60, and we can solve that. Subtract 4 from both sides. 7x equals 56, so x equals 8. So now we have a bunch of these type of problems. So I just like to use the fact that if it's equilateral, your angles are all equal to 60. But the long way to do it is to say, well, if it's equilateral, they're all equal. So we could do that and sum that to equal 180. It's just a lot more work. So I'm going to stick with just setting the angle equal to 60. So n equals 12. Number 6, I have an equilateral triangle, so that means all my angles should equal 60 degrees. Oh, that's a 6. All right, add 6 to both sides and divide by 2, so x equals 33. Now 7 and 8 are a little bit different. Instead of telling me the sides are congruent, it tells me my angles are congruent. But remember, if my angles are congruent, that means my sides are congruent. So what does congruent mean? It means that their measures are equal, so I can set them equal to each other and solve. So minus the 5r and divide by 2. Last one, we have equiangular, which means that it's equilateral, which means my sides are congruent, and I can set them equal to each other and solve. Oops, I just realized here we just solved for r. Go back here. So we found 2 is r. Now we need to actually plug it in. So 5 times 2 plus 8 would give me a final answer of 18. There we go. I caught it on this one. So 10, subtract the y, 3y plus 1, subtract 1 from both sides, so y equals 3. But it asked for mn, so I need to plug that in. 4 times 3 plus 1, so that would be 13.